Hi, welcome back, everybody. Hope we've got our caffeine on and we had a fun time wrangling up some cold brew during the break. The puns are not going to stop today. I'm sorry. This is just what you're going to have to deal with. I am really excited to be now extra caffeinated to introduce our next speaker, Monica Powell, who's an amazing speaker and software engineer that I'm really excited to hear her talk today. I hope you all are too. Monica is like, I think, everybody here today who's coming together for this amazing community is also one of these speakers who thinks a lot about community and how we can build it and how we can empower people. So really excited to hear what she has to say for us today. Monica has contributed to all kinds of projects to elevate people, including increasing access to ebooks at the New York Public Library, which is super awesome. I don't know about you, but I love the library. I miss the public library a lot in these pandemic times. So that is really cool to see. She also creates tools to support meetups community organizers and runs a React.js community for women and non-binary React developers, and is also a GitHub star. So wow, what an impressive bio here we've got for Monica. So I am really excited to be introducing Monica for her talk, Keeping Static Site Rendering Cool with React Hydration. And don't forget, hydration is not just for React, it is also for humans. So as you're drinking your coffee, you might also want to switch it up and drink a little water too. All right, so I'm going to stop rambling about hydration for humans because we want to hear about React hydration from Monica. First, another beautiful musical intro from David.
Hi, I'm Monica. I'm a software engineer and community organizer. I'm passionate about making technology like open source more accessible, and I created a meetup group, React Ladies, for women and non-binary React developers. So the purpose of this talk today is for me to share some helpful things you should keep in mind to render a seamless server-side experience. Server-side rendering can be powerful, but it does require thinking in multiple contexts. So I will be sharing some of the gotchas I've run into while developing server-side rendered websites. So let's take a step back. First, what is server-side rendering? When a server generates the initial HTML that loads in a browser, that would be considered server-side rendering. So frameworks like Next.js and Gatsby.js support SSR out of the box. So why server-side rendering? A couple notable benefits of server-side rendered applications is that they tend to load initial content faster and lead to higher SEO rankings. So in contrast, a website that only supports client-side rendering requires visitors to have HTML enabled in order to view content on the site. Note, visitors may see a largely blank page if they do not have JavaScript enabled. So if you go to a client-side rendered application, for example, a website created from Create React app, you'll notice very little HTML markup in the DOM. You'll see the root where the React is injected, a message saying you need to enable JavaScript to run the app, as well as script tags that link to the JavaScript that needs to be loaded to hydrate the page. So let's walk through what happens in a server-side rendered application like Next.js or Gatsby when all the pages for the site are built at once in the server. So first, you write the site in React. Then Gatsby creates a production build of your site using React DOM Server, a React server-side API, to generate HTML from React. When someone visits your website, the first thing they'll see is the HTML generated from the server. Then, once JavaScript has loaded, the React DOM Hydrate API kicks in to hydrate the HTML page that was rendered from the server with JavaScript. After hydration, the React Reconciler APIs take over and the site becomes interactive. Let's take a look at what happens when JavaScript is enabled or disabled in a server-side rendered app versus a client-side only rendered application. I use Gatsby and Create React App for these demos. So, JavaScript is toggled on and off. We see there's very little visible change on the left side, which is a Gatsby-powered site, aside from the image loading. On the right, we see a client-side rendered Create React app where the browser is responsible for constructing the initial HTML. Due to this, we see the bare bones HTML as opposed to a full HTML document when JavaScript is disabled. So we just looked at an example of server-side rendering that looked great in production in both with JavaScript enabled or disabled. What could go wrong? There are some common issues you might run into with server-side rendered applications that only occur during the initial hydration process in production, or errors that appear at build time. Something helpful to keep in mind is that there's some data that just isn't available in the static server context, like user or browser-specific data. For example, window size, authentication status, local storage, etc. In this image of Target's navigation, you'll see that the store location data, my username, and items in my shopping cart were not available on initial page load. Patterns like this can be common on server-side rendered applications. Let's debug this hydration issue that was happening on my site and causing unnecessary rendering changes during load. A huge piece of missing data that can cause issues in server-side rendered applications is missing JavaScript. It's a best practice to load CSS before JavaScript. Therefore, you need to consider how the HTML and CSS on a page load before JavaScript is available, since JavaScript is not required for the page to load. You may end up noticing weird changes on initial page load that change too quickly to properly inspect, especially if you have a faster internet connection. But there are ways to slow down and really see what is going on. I'd recommend disabling JavaScript in your browser or using a site like Web Page Speed Test to generate film strips, thumbnails that show you exactly how the page is loaded step by step. So this is a waterfall I took of the issue on my site with Web Page Speed Test before the issue was resolved. You can see one of the issues is that the size of the icon drastically change as the page loads, which can be a disjointing experience. Ultimately, the solution, once I disabled JavaScript, I was able to discover that the way that the icons looked before they were fully loaded mirrored the app without JavaScript. I determined Font Awesome was using its own styling that was coming in through JavaScript. And in order to resolve the issue, I disabled Font Awesome's external CSS since it's loaded via JavaScript, and replicated the CSS styles I wanted locally. Since CSS loads before JavaScript, inlining the styles resolved the issue. So you'll notice that after removing the dependency on Font Awesome CSS, that the styling of the icons is consistent as the application loads. The previous issue is related to a much larger issue of handling layouts on the server side. You can minimize layout shifts by avoiding using JavaScript to position or style content instead of CSS. It is common for some data to be unavailable as the page loads. You should consider developing in a way that can handle missing data by leaving room for data to come in. For example, in the target navigation example we saw earlier, there was no shift as the user and store specific data loaded. If you write React, you may have conditionally rendered content like this based on screen size using the Media API. However, the Match Media API can't reliably detect the browser or device size in the server context, which can lead to some strange rendering issues as the page loads if the originally set media size doesn't match the actual browser. It is preferable to use CSS or a library like Fresnel, which wraps all the media components in CSS instead of Match Media and server-side rendered applications to lay out content. Since CSS loads before JavaScript, styles applied via CSS, unlike JavaScript, should visibly match what you expect on the page on the initial load. Let's walk through an example of how Fresnel can be used. First, you need to import Create Media from Fresnel, where you will then define the breakpoints and export Media Context Provider from this object. Your whole application will be wrapped within the Media Context Provider, which then allows you to reference Fresnel's media component throughout your app to render components based on your predefined breakpoints. The final step, which you can read more about in the Fresnel docs, is passing media style into a style tag in the head of the document so that CSS can be generated from Fresnel markup and be rendered on the server. So another issue you may run into is if you try to access browser-specific elements in a server context, JavaScript will not be able to resolve those elements. In particular, you may run into window is undefined or browser is undefined errors, which happen when you try to reference these browser-specific elements. This is because your app is assuming that these things are defined, but they are not available in the server. Your first inclination to resolve the undefined window error might be to write something like, if type of window does not equal undefined, render this, else don't render this. However, the Hydrate API that converts HTML to full-fledged React expects that the content is identical between the server and client and does not guarantee that matches will be patched up in cases of mismatch. Due to this lack of guarantee, it is not a good idea to conditionally render based on elements that will differ between the server and client and may lead to some unexpected behavior. In order to avoid the issues that happen with the hydration reconciliation process, if you do need to access browser-specific elements, you can wrap any side effects that rely on things such as window or document and a USEEFFECT, since that only fires after the component has mounted. This is an example from the React docs of referencing a browser element document title within USEEFFECT. This code will never be executed on the server and will not run into issues that it is referencing document, which is undefined within the server, because this code is not run. So I wanted to close out with some words that I recently read in a blog post by Ian Bean. JavaScript is a powerful language that can do some incredible things, but it's incredibly easy to jump to using it too early in development, when you could be using HTML and CSS instead. Consider the rule of least power. Don't use the more powerful language JavaScript until you've exhausted the capabilities of less powerful languages HTML. So there is actually a rule of least power within the W3C specifications if you want to get more information about how to approach development through this lens. So I recently used the rule of least power when I was revisiting the header on my website. I wanted to figure out how I could efficiently load different header images based off of the screen size, and I ended up discovering that I do not need to use JavaScript in order to do this in a performant way. So I was looking into how to display different images based on screen size, and I stumbled upon HTML art direction, which can be used to dynamically load images based on the screen size using just HTML attributes such as source set instead of needing to pull in JavaScript. The cool thing about the HTML approach to changing the images is that it can improve page loading performance, as it allows the browser to only preload the image that is visible within the viewport. This can be especially beneficial if you need to display multiple images at various places within a site depending on the screen size. In order to set up this functionality in HTML, you can use the picture attribute and set media queries on each source image. It will return the first condition that is true, and as a fallback, it will return the image from the image tag. So if the screen size is greater than 625 pixels, then in this example, it will return Anna Monica full. But if the screen size is less than 625 pixels, then it will return the cropped photo. And as a fallback, it will return the Anna Monica full image if for whatever reason, there is no browser support, or if neither of those conditions were true. It's also possible, if you're using Gatsby, to use art direction within Gatsby Image, which is their package for loading and transforming images from GraphQL. So this is an example of a query that is getting multiple images, and then there is some markup that is passing in the multiple images that were queried and transforming it to be similar to the HTML that we saw in the previous slide. I definitely recommend checking out Gatsby Image if you are using Gatsby and are interested in exploring performant ways to initially render images aside from just art direction. So in summary, in a server-side rendered context, it's important to consider how the page loads and when data is or is not available. CSS is probably the right tool for handling the layout and styling, So definitely reach for that first, or reach for libraries like Fresnel, which are applying CSS on your behalf as you write JavaScript. You want to guard references to browser-specific elements like document or window within USEEFFECT to avoid reconciliation errors as the page hydrates. Here are some resources I recommend if you're looking to further explore the rendering process for server-side rendered React applications. So I would definitely recommend looking at the Gatsby docs if you want to have a better understanding of how they're using the React Hydration API. Josh Camus also wrote a great article about the perils of rehydration that walks through how they were able to resolve some issues that they were experiencing, and shows great examples of what happens when you don't necessarily properly handle the missing data at different points within the hydration process, as well as going directly to the React documents where they walk through what the reconciliation process is and what are the things that you need to be aware of. So I definitely recommend that if you're looking to incorporate server-side rendering into a new application or looking to convert an application. The web page speed test or web page test is where I got the thumbnails for my earlier examples. So I definitely recommend that if you're trying to get a better sense of how your page loads for different types of users, as well as getting that really nice waterfall that you can export. As well, you can get a video of how your website loads. I found that very handy. And then if you are looking for a CSS solution on the server side, definitely check out Fresnel and read their docs for more information about their approach to CSS in the server. So thank you, React Rally, for having me. You can connect with me on Twitter at waterproofheart and view the content of this presentation at monica.dev/reactrally.
Thank you so much, Monica. What a great talk. So much practical, awesome info for how we can do server-side rendering. And I love the implication that this kind of makes our sites hopefully more accessible to more folks, less dependent on that client-side work.